Hey guys, I'm not sure if anyone's been missing or looking for these videos, but um, here's going to be a video. This is going to be a video on the homework for 2.4b, solving systems of equations with three variables. Alright, I'm going to solve most of these by elimination because that's my preferred method. Alright. Jumping into this one right here, I'm gonna get rid of the x variable. I think you could choose to get rid of any variable for this one, honestly, but I do know that the x's can cancel here if I add them together. You can also see that if you decide to get rid of z's, those will also cancel pretty nicely. So either way would work. But I'm going to start by adding these together. So that's going to give me 3y, and then that's going to give me negative z, and then equal to 7. So this is the first new equation that I've made without x. I need to make another one without x too. So to do that, I'm going to multiply this by 2. Okay, that's going to give me negative 2x plus 4y plus 2z equal to 4. And I'm going to add that with the third equation that we have up there. And again, if I add these together, that's going to get rid of x right there. I'm going to have 7y plus z equal to 13. This is the second new equation I've made without x. And if I stack these together, these new equations, 3y minus z equal to 7, I can right away I can add them together and get rid of z. Okay, so I'll add them together. That's going to get 10y is equal to 20. Divide by 2. And I get y is divide by 2, sorry, divide by 10, and I'll get 2, so y is equal to 2. And then I'm going to take this value right here, I'm going to choose to plug it into the second new equation, or no, the first new equation, so new equation 1, and then 3 times by 2 minus z is equal to 7. So 6 minus z is equal to 7. I'm going to subtract 6. And then I'm going to get negative z is equal to positive 1. So that means z is equal to negative 1. And then I'm going to move these values right here. I'm going to plug them into the first equation that we had above. So to solve for x. So x plus 2 minus 2 times by negative 1 is equal to 5. So x plus 2 is equal to 5. This is 4 right there, so when I subtract that, I'll get x is equal to 1. So my solution is 1, 2, and negative 1. Alright, so that's the first problem down. Let's go to the next one. I think x is going to be the best variable to eliminate. I can see that here. All other variables aren't looking quite as nice as that right there. So I'm going to first add 1 and 2 together. Get 6y minus 10z equal to 4. So that's the first new equation that I have without x. I'm going to use these two right here, but I'm going to multiply this by 2. So that's going to give me negative 2x plus 4y minus 8z equal to 10. And I'm going to add that with the second equation, which is 2x minus y plus 2z equal to -7. I can add them together now. X's will cancel. I'll get 3y, and then I'll get minus 6z equal to 3. This is the second new equation that I have. I'm going to stack it with my first new equation, which was 6y minus 10z equal to 4. I'm going to choose to get rid of y's here because 3 goes into 6. I just have to multiply this by -2. Okay, that's negative 6y plus 12 z equal to -6, and then 6y minus 10z equal to 4. Let's add them together, and I get 2z is equal to -2, and when I divide by 2, I'll get z is equal to -1. Okay, so I have one part of my solution down. I'm going to plug this back into one of my new equations. I think I'll plug it into the first one. So 3y minus 6 times by -1 is equal to 3. So 3y plus 6 is equal to 3. I'll subtract 6, and I'll get 3y is equal to -3. Divide by 3, and y is also equal to -1. Next, I will plug these two values into one of my first three. I'll probably just use the first one because x is doesn't have a constant. So x plus 4 times by -1 minus 6 times by -1 is equal to -1. So that's x minus 4 plus 6 is equal to -1. So that's x plus 2 is, whoops, don't know why I wrote -2 right there. It's equal to -1. And then I will plus 2 and plus 2, and I get x is equal to 1. These are very, very nice solutions, which we like to see. So the solution here would be 1, -1, -1. Okay. Let's move on to 3. Sorry, 1 second. Okay, so for 3, trying to see which would be the best variable to eliminate. It is kind of nice that 3 goes into 6, 2 goes into 6. That's nice. I wouldn't use z's because 2 goes into 4. That's of course nice, but neither 2 or 4 or 3 kind of share like quick, easy factors. But I do like the y's here because I have 2 without a coefficient other than 1, right? So yeah, that's looking kind of nice in my opinion. Okay, so let's let's go with that. I'm going to multiply this by -1. That way it makes this y positive, and I can add it with that one right there. So -3x plus y minus 2z equal to -4. And I'm going to add that with 2x minus y plus 3z equal to 10. So multiplying this by -1, and I'm adding it with this one right here to get rid of y. That's going to give me -x. The y's are going to cancel. I'll have plus z equal to 6. So first new equation without y, which means I have to also get rid of y in my second equation too. Okay, so let's get rid of let's use this same equation that I did right here. Okay, so I multiplied this by, let's just start over from that. I'm going to multiply this by -2 instead. Multiply that by -2. Okay, so when I do that, I get -6x plus 2y minus 4z equal to -8. And I'm going to add that with the second equation. So 6x minus 2y plus 4z equal to -8. Now, what's nice about this right here is that when I add them, things are going to cancel. That's going to cancel. That's going to cancel. That's going to cancel. This does not cancel, though. So the left side of the equation is 0, but this becomes -16. And that right there is a false statement. So this is a problem with no solution. Okay. Now, before I go on to 4, I'm going to check my work up here with 3. Something seems off right here. I'm checking my x. I think I did something wrong here. So I plugged in -1. That becomes -4. I plugged in -1. That becomes +6. -4. That's what I did wrong. Something felt off about that. This right here was supposed to be -2. -2. Therefore, x is going to be equal to -3. There we go. That feels better. -1 and -1. Okay. Sorry. Going back to 4. Let's see. I like the z's here, so look at the z's as they're stacked. I have a positive z, negative z, negative z. So I can add these together, and I can add these together. So let's see what happens when I do that. So I'm going to first add these two. That's going to give me -x plus y equal to 2. Then I'm going to add these together. That's going to give me 4x minus 4y equal to -8. Okay, so I'm going to just multiply this by 4. Get rid of the x's there, right? Multiply that by 4. -4x plus 4y equal to 8. 4x minus 4y equal to -8. And add them together, and you'll notice those cancel. Only this time, everything cancels. So I end up with 0 equals 0, which is an infinite solution. Alright, perfect. Solve the system of the linear equation using substitution method. I'm probably going to use substitution method with 6, probably not with 5. Again, I don't mind which one you pick, but it's just substitution is kind of messy with something like this right here, so I'm going to opt to not. Okay, so using substitution, I think x's are going to be the easiest ones to eliminate because I like how those ones don't have coefficients other than 1 and -1. Right away, I can just add them together. So if I do, I get -y plus z equal to -6. Then for my second new equation, so this is going to be my first new equation. For my second, I'm going to multiply this by 3. -3x plus 15y plus 9z equal to 6. So this is the second new equation. No, it's not. Just kidding. I need a second new equation, and I'm going to add this with the third equation. That's how I'm going to get that. add these together, those cancel. I get 13y plus 13z, and that's going to be equal to, oh boy, I hate almost messing up on these. That's a negative 4z right there. I had it as positive 4z. That's 5z. That's going to be equal to 24. This is my second new equation, and I'm going to add it with my first new equation, which was negative y plus z equal to negative 6. I'm not going to add them together just yet. I'm going to multiply this by negative 5, and I'm going to get rid of z's. So the top equation is going to stay the same. And the second equation, that's going to be 5y minus 5z equal to positive 30. I'm going to add them together. That's going to give me 18y. Those are going to cancel. And that's going to be equal to 54. Divide by 18 on both sides. And I get y is equal to 3. So y is equal to 3. I'm going to plug this back into probably this spot right here. So negative 3 plus z is equal to negative 6. And I'm going to add 3 and add 3. Z is going to be equal to negative 3. And then I'm going to plug those values into, I'm probably going to use the top equation. So I have x minus 6, y was 3, minus 2, z is negative 3, equal to negative 8. So I have x minus 18 plus 6 equal to negative 8. These can combine to be negative 12. I can add 12. And I'll get x is equal to 4. So my solution is 4, what was y? 3, and z is negative 3. Alright, this one I'm definitely going to use substitution. I'm just going to plug 4 in for x. So I get 4 plus y is equal to negative 6. Subtract 4, I'll get y is equal to negative 10. And I can plug those values in here. So x was 4 minus 3 times by negative 10 plus 2z equal to 26. So that's 16 plus 30 plus 2z equal to 26. And that's equal to 46 when I combine these terms right here. And then I can subtract 46. 2z is equal to negative 20. Divide by 2. And I get z is equal to negative 10 as well. So my solution is 4, negative 10, negative 10. Alright, jump in here. These ones are definitely, I'm going to solve by elimination. Okay. Let's look at these variables. I think x is the one to go and eliminate since 2 and 4 go into each other. Let's start by multiplying this by 2. That's going to give me negative 2x minus 4y plus 6z equal to negative 40. I'm going to add that with the first equation. and then add them together. Those cancel. Negative 5y plus 5z equal to negative 25, right? Okay, and then I'm going to multiply this by 4, and then that's going to give me negative 4x minus 16y plus 12z equal to negative 80. I'm going to add that with the second equation, 4x plus 5y plus 2z equal to 10. Those are going to cancel. That's going to be, what, negative 11y? And then plus 14z equal to negative 70. So these are the two equations that I'm stacking, the two new equations. So negative 5y plus 5z is equal to negative 25. We have larger than usual numbers here, which is fine. Just hopefully we're doing this right. That's the scary thing about large numbers, is sometimes you feel like you're doing it wrong. And I'll be honest, I kind of have that feeling right now. I'm gonna go back and check my work before I get too deep into this. I'm gonna just check it really quickly. I multiplied this by 2, right? That gave me negative 2x negative. Whoa! Right away, I caught an error. That right there was supposed to be negative 8. That was supposed to be negative 8. And then that's, okay, that would change that to be negative 9 right there. Negative 9. Y, that's negative 9y. Whew. So sometimes when you see large numbers, maybe you did something wrong. That's negative 9y, right? Those did cancel. That became 6 negative z. Okay. And then I multiplied by 4, right? I multiplied this by 4. And that gave me negative 4x minus 16y plus 12z minus 80. Okay. I think I'm good. So negative 4x, that's what I got there. And then I got minus 16y, right? Plus 12z. Alright, well, let's send it and let's see what we get. Hopefully some good numbers. Let's add these together. We can't add them together. What am I talking about? We have to, oh my goodness, these numbers are going to get way worse, guys. Whew. We have to get these to be same. This is looking bad. I'm going to multiply this by 11, which is unfortunate, and multiply this by 9, and I'm going to get rid of my y's. So that's negative 99y plus 55z equal to, let me get a calculator. Okay, we're going to do 25 times by 11, and that's negative 275. 99y, and then 14 times by 9. That's plus 126z equal to 9 times by 7. That's 63, so negative 630. Let's add these together. Those cancel, and 55 plus 126. Okay, I get 181z. This is kind of getting scary. These numbers are big. I don't like that. 630 and 275. Ooh, negative 905. That does not look like it's divisible by 181. Oh my gosh, it is. If you divide by 181, you get z is equal to 5. Oh man, that was scary for a second. Okay, so z equals 5. I'm going to plug that right here. So I have negative 9y plus 25 equal to negative 25. Okay, I'm liking this so far because when I subtract 25, oh, I was liking this. Z is equal to 5. Man, I still feel like... Okay. Yep, I'm glad I was wrong. That's negative 5. I keep missing so many things. That's negative 5, which would make this negative 25 whenever I plug it in. That's a negative 25. Okay, plus 25 now. Plus 25, that's what I wanted to see. So negative 9y is equal to 0. Divide by negative 9. Y is equal to 0. Go back up here. Let's take the... let's take the bottom equation right there. So, that's a lot of space I've used. So negative x minus 4 times by 0 plus 3 times by negative 5. And that's equal to negative 20. So negative x, that's gone. Minus 15 is equal to negative 20. Let's add 15. Add 15. What am I writing? So I get negative x is equal to negative 5. So x is equal to 5. My solution is 5, 0, negative 5. Alright, let's try 8. Hopefully it's not that as hard as that one was. I'm going to stick with x's here. Those ones look like they... Honestly, all of these look kind of like nice. Honestly. Those look pretty good with the y's. Because I can add these together. They'll cancel. Then multiply this by 2 to get rid of that. Okay, I'll get rid of y's. So when I add these together, okay, look at that. The x is going to cancel. The y's are going to cancel. The z's are going to cancel. Oh, that means that that's going to be 0 is equal to negative 3. And that's not true. No solution. Oh my gosh, that was way quicker. Alright, sweet. Number 9 is not something I have to do. This is the story problem. To set it up, we're going to treat this like a system of equations. 3 orders are placed. 2 small pizzas, a liter of soda, and a salad cost $14. So if I interpret that, I'm going to say 2x plus y plus z is equal to 14. The next order was 1x plus a liter of soda plus 3 salads is equal to 15. And then 3 small pizzas, so 3x plus y plus 2z is equal to 22. Okay. Did I have that all good? I think so. I think the easiest to eliminate here would be y. So I'm going to multiply this by negative 1. So that's going to give me negative x minus y minus 3z equal to negative 15. And I can take this equation and add it to those to get rid of y. So when I add them with these two together right there, negative x and 2x is x. The y's are going to cancel, right? Negative 3z and positive z, that's going to be minus 2z, and that's going to be equal to negative 1. Okay, I'll add this with this equation. 3x and negative x, that's positive 2x. Y and negative y, those cancel. And then I'll get negative z. And that's going to give me 7, I think. Right? 22, negative 15. I think that's 7. Okay, so then I have these right here. I think I'm going to multiply this right here by negative 2 and just get rid of x. So negative 2x plus 4z equal to 2. And then 2x minus z is equal to 7. If I add them together, the x's will cancel. I'll get 3z is equal to 9. That means z will have to be equal to 3. Okay, so the salads are worth $3 each. Let's go ahead and plug this right here into probably this one right here. So now let's plug into the first one. So I get x minus 2 times by 3, that's equal to negative 1. So I get x minus 6 is equal to negative 1. Let's add 6 and add 6. So I get x is equal to 5. So the pizzas are worth 5. And then the salads are worth 3. Let's see the sodas. So I'm just going to go back up here. I'll just take the first one. So x is 5 plus y plus 3. Salads were worth $3. That was $15 in total. 5 plus y plus 9 is equal to 15. These can combine. I get y plus 14, right? Y plus 14 is equal to 15. So the sodas are worth $1. There you go. I think I'm just going to leave it like that. And I think that's all for this homework. Hope it helps.